Hello, if you are coming into my stream tonight, I'm willing to do a test review and talk through some problems for tomorrow night's test. A little bit of background music. That's a little bit much though, isn't it? Let's go with something different. All right. And I'll just wait for folks to come on and I will take questions as they come. Whenever you want to ask questions on, I'll be glad to discuss. So what I'm going to do right now is I'm going to pull the chat up. I think I've got everything laid out the way I want it to. I got to set up my Doceri. And while I'm doing that, I'm going to mute myself and block the camera and just wait for folks to come on. So as soon as you come on, if you're a student in my face-to-face, any of my face-to-face courses, just give me a hello in the chat. Let me know who you are. First name or initials is fine, just so I know who it is. So, all right, I'm gonna pop off, take the camera off. I didn't even have the mic over close to me. Now I'm kind of moving everything around, so should be okay now. Yeah. And I'm going to do a setup, and I will be right back. All right, I'm going to go ahead and get started. I will take the music and dial it back just a little bit. It's way back in the background. And I'll bring chat back up. And I am ready. As soon as anybody from class comes in and asks a question, I will gladly discuss whatever you've got. Get my iPad in place. And I'm going to walk through just a couple of problems while I'm sitting here. It is right at 7 o'clock. So, and by the way, we've got intense storms coming through tomorrow afternoon. I don't know if you guys have glanced at the weather, but through my job, I've gotten a lot of additional intel, I guess. And they're talking about very high winds, wind gusts, possible tornadoes, things like that. So be safe out there tomorrow. We'll see. Hopefully they don't do away with tomorrow's class. We're supposed to have a test. If they do, I will say this. Sorry, it's my phone. If they do, then I will place the test online. I'll do it through my stat lab. I'll try to be very selective in my problems, and I'll probably put some of my own up there instead of having the from the test bank, so that I can be very specific about what I'm asking you for, what I'm testing you on. So, but I just thought about the fact that if those storms come in, we may actually have another Wednesday that's out. Boy, that'd be interesting. So anyway, let me get started. I'm going to do a problem here that deals with some of the probability concepts that we talked about. I don't know that I'm going to kick back with any review tonight unless you have questions on box plots and measures of position. I think we covered that pretty handily way back when. There'll be a little bit of it on our test tomorrow, but it's a very simple, what I get you to cover with measures of position is very simple in terms of what we do for the rest of the class. So I'm going to talk about right now, let's see, what do I do? I'm going to put the information from a problem that I've got on my notes up here. I'm not going to write the whole problem out. I'm just going to put the pertinent information. So, excuse me. 81% of households in the United States have computers. Okay. 81% of households, right? Yeah. Of households in the United States have computers. It's probably more than that now. It's an older problem that I use. Of those 81%, 92% have internet access. Okay. 92% have internet. And the question is, find the probability that a U.S. household selected at random has a computer and has internet access. Okay. Let me see. Of those 81%, 92% have internet access. Sorry, I've got text coming in. Study found of those 81%, 92% have internet access. If you're trying to figure out, excuse me, off the top, this is a former textbook problem, so this is not an overly tough one. But sometimes there are assumptions to be made within the problem, and it's easy to overanalyze. And I try not to go through too many of those. But if we're looking at a study found that 81% of households, okay, so let's just look at this. So you're randomly selecting one household. So you've got an 81% chance that it has a computer, which leaves you a 19% chance that it has no computer. Okay. If you choose one at 0.81% that has a computer, then 92% of those, oops, I don't know why I put an arrow, have internet, and 0.08% have no internet. We're not even concerned about down here. There's no concern for us whatsoever. So we are looking up top, and we are looking at the probability that we choose one. Yeah. U.S. household selected at random has a computer and has internet access. So has a computer and internet access. Okay. Well, that is just equal to the probability of computer times the probability of internet access. And all we do in this case is take this and multiply it times that. So hopefully you can see the calculator okay up there. I think I've got my lighting okay for it. It's a little smaller, but 0.81 times 0.92, 0.7452. There's the answer. Okay, an example of the multiplication rule. All right. Still just one person. There's one person showing in the stream. It might be me. So I'm going to close out of Twitch so I can kind of keep an eye on. I think it's me. 9 times out of 10, it's me and just me. So there's an example of multiplication rule. And this video will remain up here. So if anybody's not able to get on, at least you'll see a few that I've worked through. Let me run through my notes here. I think I'm going to move on. I did one for a multiplication rule. Nobody's come on yet. Still showing one on. Just don't know who you are. Let's talk about addition rule. That's the next area. Let me choose my next problem. And just to let you know, if anybody's saying, why didn't he have these lined up already? I have a whole smorgasbord of them lined up. But typically in these sessions, especially right for a test, I just want your questions. What do you got? What do you want? Let's look at Cartan defects. And I should be able to walk through this one. Let me see here. I'm going to pull back off of that. I'm going to go to I'll just pull it down. Can't seem to get it to switch screen, so I'll pull this down. I'll maximize it. I'll click on it. I'll make it bigger. Then I'll see if I can. Whoops. Well, there we go. That's probably too big. But I'm going to look at Cartan defects here. And I've made it way too big. There we go. Okay. This is a favorite of mine, Cartan defects. So we'll look at this one. So a company that makes cartons finds that the probability of producing a carton with a puncture is 0.05. The probability that a carton has a smashed corner is 0.08. And the probability that a carton has a puncture and has a smashed corner is 0.004. A, are the events selecting a carton with a puncture and selecting a carton with a smashed corner mutually exclusive? Explain. I'll come back to that. And then the second question, if a quality inspector randomly selects a carton, find the probability that the carton has a puncture or has a smashed corner. So here we are looking at an OR situation, which means we're looking at the probability of event A or B, and that's equal to the addition rule, probability of A plus the probability of B. Subtract out the overlap, because if they're mutually exclusive, then they stand alone. There's no overlap, and that overlap of A and B is just going to be 0 and go away. Then we're just left with this right here. So we have to determine if they're mutually exclusive first. If they're not, then we have to find out what the probability of A and B is, and then subtract that out of our sum. Okay? So let me get this out of here. I'll come back to it in just a second. Okay. Are the events selecting a carton with a puncture and selecting a carton with a smashed corner are mutually exclusive. In other words, can I select a carton that only has a puncture without any probability of having a smashed corner? And the answer is no. At any given time, the box could have either one of these events happen to us. So they're not mutually exclusive. Rolling a die, spinning a spinner, two mutually exclusive events. One doesn't affect the other. But in this case, one does affect the other. These are in other words, you could have both of these occur at the same time. I had to think of my verbiage. You could have these both occur at the same time. You could have a puncture and a smashed corner. Therefore, they're not mutually exclusive. So, are mutually exclusive? No. And hopefully that explanation is okay for you. If a quality inspector randomly selects a carton, find the probability the carton has a puncture or has a smashed corner. So we're looking at 0.05, 0.08, and 0.004. Oops. 0.05, 0.08, 0.004. These were our numbers from our problem. Shoot. Can't remember which is which. Doesn't matter. Doesn't matter whether this, we'll just put this as the punctures. Mathematically, it's not going to matter is what I should say. This is going to be the crushed corner. And this is going to be both. Okay. So the probability of event A or event B happening is the probability of event A happening plus the probability of event B happening. Subtract out the probability of A and B both occurring at the same time. Okay. We're given specific numbers. We don't even have to figure this out proportionally because we're given exactly what we need. Excuse me. Probability of punctures is going to be 0.05 plus the probability of a corner being bashed in was 0.08, and the probability of both of them occurring was 0.004. Okay, so back to the calculator. So we are exact. Let's go a nickel plus 8 cents. Subtract out 0.004. 0.126. 0.126. So there it is. That's the addition rule in action. Went over mutually exclusive events, talked about the context of the problem to some extent, and then there's the form that I've laid out for you. Filled in the blanks, which this was very easy because you didn't, with the cards it becomes a little bit harder only in the sense of you have to determine how many clubs there are, how many twos there are. If I pull one and toss it, how many are left? What's my denominator in the second, etc. So this is just laid out for you. This is very, very much a great textbook type problem. So there's that. Okay. All right. I will scroll a little bit. And I'm actually going to go to the next section. I'm just going to scroll through. Nobody has showed up tonight, which is okay. This will be out there for you to catch up on. Permutations, combinations, nope. I want to go straight to probability distributions. I know this is fun to watch me scroll through. Sorry, I've got calls coming in. Apologies. Oh, because I was still in chapter 3. I was trying to figure out where are my probability distributions. And there we go. All right. Vocabulary. We talked about discrete and continuous quite a bit in class. Random variable X represents a numerical value associated with each outcome of a probability experiment. What we've covered quite a bit in the classroom itself. This right here, I don't necessarily need to review it, but don't forget it. The probabilities in a discrete probability distribution should all fall between 0 and 1. That's a given. That's where your probability is going to fall anyway. And the summation of all the probabilities should be 1. Now, we're working in the lecture piece of class in normal distributions now, which is continuous. The summation of that normal curve is 1 underneath as well. So really this kind of stuff carries on. It's not just limited to the discrete, but these are constraints that must be held specifically in these discrete probability distributions. Let's take a look at this. Here is a discrete probability distribution right here. We've drawn these and built these in class. You've had these to work, excuse me, in the MyStatLab. For those of you who stayed up with the work and completed it, thank you. All the probabilities, 0.16, 0.22, 0.28, and so on, add up to be 1. And all the probabilities from the start to the finish are all between 0 and 1 inclusive. So these fit the constraints, and you assume that these are all correct. Assume that the person who did the work proportionally did it correctly. Okay. Okay. I'm going to look at these right here. I'm just going to walk through some very simple, what I consider to be very simple examples. Decide whether the distribution is a probability distribution and explain your reasoning. Okay. We'll look at number 1 right here. Is it a probability distribution? Well, let's take a look. I need those probabilities to fall between 0 and 1, and looking at them, they do. That's easy glance, 0.28, 0.21, 0.43, 0.15. Do they add up to be 1? At a glance, they do. And remember, rounding can throw this off slightly, but you should not be that far off. That's 1.07. That's too far. That's not a probability distribution. 1.07. Now, I don't know what rounding went into place or what work happened. So you could probably justify the other side that this is. And because I rounded here and here and here earlier, this is why I ended up with what I've got. But just right off the cuff, 7 cents into that second dollar is too much, in my opinion. And I did the numbers right. Let's look at the second one. Well, the second one right here is not a probability distribution because of that negative number. You can't have a negative probability underneath there. All your probabilities fall between 0 and 1. That's easy. This next one down here. Off the top, it looks okay, but we need to add those. Excuse me. We need to add those fractions. So we got 1/16 plus 10/16. I just take 5/8 right there, change it to an equivalent fraction with 16 as the denominator, plus 4/16. The change in the dividing, no, there's nothing to that. And then 1/16. 1/16. Okay. Now add those together. 10, 14, 15, 16, and I get 16 over 16. That is 1. So the sum of these probabilities is 1, and all of those probabilities fall between 0 and 1. So that one could be a probability distribution. And then the last one. Get rid of everything up to this point, and we'll just go straight to the last one. Number 2 here. Gosh. Explain your reasoning. You've got 9 cents, 36 cents, 49 cents, and 6 cents. We're going to add that up. They all fall between 0 and 1, so that's okay. 0.09 plus 0.36 plus 0.49 plus 0.06. Yay, easy. That adds up to be 1. That is a probability distribution. Okay. Easy examples there within this old text that I've got. Let's talk about this real quick. The mean of a discrete probability distribution. And remember, as you're taking your test or any assessment on this, we've worked through regular probability, discrete probability distributions and specifics with the binomial. Now, the one thing you're going to have to determine is, am I dealing with a binomial or just a regular discrete distribution? Because the means are different. The mean of a binomial distribution is NP. Very easy. Here it is. The mean of a discrete probability distribution is the summation of the x times the p of x's. And if you remember, in class, we spent quite a bit of time in that class on transferring this to TI-84 speak. So in other words, we're looking at the summation of all the x's that we put typically in L1 times L2. So we're looking at that, the summation of those. And we'd get them all out to the side, then we would have to take a sum, sum of L3, typically if we're working with the first 3 columns. That is terrible. It looks like sun. All right. Not too hard to find. I'm not going to be giving examples that are so complex that you couldn't work them out a piece at the time. But if you had to, I would recommend using the TI and doing it just like we did in class. We worked through several of these. I remember going through them. So I think you'd be okay with those. Moving into the standard deviation, or actually the variance and then standard deviation of a discrete probability distribution. You're looking at this. You need to know these. So I'm going to reply to my announcement that I sent out with this link for the online office hours tonight. And I'm going to put on there, because I don't think I said anything last Wednesday, but you can bring a 3x5 card, fill it up front to back with whatever you want to use on this test. It's no problem. But I'll send that out on the announcements. Hopefully people will check their stuff tonight. And that's it. All right. Oops. Oh, shoot. Well, I'm not sure what happened here. Oh, I didn't realize. Timeout. I didn't realize in Doceri I could focus like this. Huh. It's not showing on there, though. Okay. No problem. Just for me, but okay. Scrolling down, expected value is just the mean for discrete probability distribution. And then I'm not going to do a problem out of there. I think I've walked through several. If you, one that I didn't do is if you're missing a probability, just one, you can figure it out because you add up all the probabilities around it, then subtract from one, and whatever's left, whatever was missing is that subtraction, whatever you get from that subtraction. These are things we've done, so this is not initial. So if anybody comes on here and says, man, I need more instruction, we did all this in class. This is just a review with nobody here, with no questions. All right, binomials. Let's stop right here. A binomial is repeated for a fixed number of trials. We talked about that. Fixed number of trials. Each trial is independent of the others. There's only 2 possible outcomes, success and failure. That's it. The probability of success is the same for each trial. So if I'm flipping a coin, that's an easy binomial. I can flip the coin 4 times. N would equal 4. And I would have the same probability of success each time, 50%. And the random variable x counts the number of successful trials. All right. I think that's it. It's about 7:30. Nobody's come on yet. I've done kind of a quick pseudo review. Not a whole lot to this. I do apologize. I like to do more of these. They're certainly optional for you and me because it takes up our time outside of class. but I like to have these available a little bit more than I have so far this semester, because I want you to be able to come on here at your leisure from a distance, not worry about anything, and ask questions as you can. And if you notice, the second chat down, there's a link to join. So you're able to join my stream, and we're able to talk through things, because typing up and trying to get your thinking into the typing and the verbiage using words is not always easy. It's easier to use symbols or to walk through it. You can say, go back to that one. No, go back up, the second one over. And we can walk right back through the steps of anything that I've worked or anything you want to talk about. So with that said, I'm done for tonight. I did try to offer a little bit. We've got a test tomorrow night, but again, we've got a lot of weather coming in Eastern North Carolina tomorrow. And from the text that I told you we're rolling in earlier, people were texting me, people at my institution who were saying, I think the big stuff's supposed to roll in at 4 tomorrow. Well, our class is at 6 tomorrow. So watch the weather alerts on Pitt Community College website so you can see anything that comes up weather-wise. Tomorrow is a test, and tomorrow is actually the follow-up to normal distribution lesson from last week. No problem on my end. If we do not have class tomorrow night, I will post my test online. I will post it. I typically have you do one through my stat lab. I'll see if there's a different way to do it, because I don't mind just posting the test itself, have you show your work and get it back to me. Excuse me, but we'll figure that out. I'll figure that out. Not an issue. And as far as the normal curve goes, I can post some videos up here on the normal curve to cover for instruction missed for tomorrow night. So I don't want anybody to be unsafe trying to get to class. So please watch the Pitt Community College website. Make sure that you are keeping up with any updates they might have. So I'm going to disconnect from Doceri. I forgot what that'll do up here. Fixing to find out. But I'm done. Thanks for anybody who stops by after the fact to watch this video. I do have the link in your announcements. And again, I will try to get on and do a few more of these and leave some videos as we go so you can kind of follow along and might help you with some of your work. One last thing, for those of you who have been asking about my stat lab, who may have missed an assignment, who worked really hard during that week and just never got to it, I will say a way around that is to do just a little bit each day. You've got to really work on time management with that stuff, especially in a math class. But I will open those back up only after you have shown me on these upcoming My Stat Labs that you'll get in it consistently and you weren't just kind of slacking off. So once you show me that, I'll gladly open them back up and let you go back in and practice them, especially as we get closer to the cumulative final. So that's it. That's all I got. I appreciate anybody that stops back by. And I've got one viewer, whoever that is. Thank you. I can't tell who it is on my restream here. But have a good night. Be safe tomorrow in any kind of weather that comes up. And I appreciate you.